So our final question deals with this Luria-Delbruck fluctuation test. So if you remember how this test works, let's just focus on the middle line, since this is hypothesis true that resistance arises from random mutation. This turns out to be the correct one, so let's just focus on this. So the way this was demonstrated is by growing cultures of bacteria from single bacteria and letting them reproduce through binary fission to generate large numbers of bacteria, say maybe 1 million or so. And then some of those cultures, in the course of their growth, some will have mutations fairly early in the growth of the culture, which will provide resistance to an antibiotic or a bactericide of some sort. And in this case, some cultures, if the mutations happen early, will generate a very large number of colonies which are resistant, maybe something like this over here, whereas some will have mutations that occur later in the growth of the culture and give rise to a smaller number of smaller number of resistant colonies, whereas other cultures in the course of their growth, they may not have had any such mutations, in which case you get no colonies that are resistant. Now the key to this, the fluctuation in the fluctuation test, deals with growing these many cultures independently. That you many times allow a culture to start from one bacteria, generate to many, and then look to see how many resistant colonies you get out of it. And it's this fluctuation between very large numbers of colonies and no colonies at all that provides the data for the fluctuation test, in that mutations are occurring randomly throughout the growth of the culture. So with all this in mind, let's go back and look at the question itself. So the researcher plated 20 small flasks of bacteria from the same colony and let them grow overnight. So this would essentially be these 20 cultures which are all growing independently, so we're going to see how often these mutations come up. The next morning, the researcher noticed that all but one of the flasks had come open and were ruined. Not wishing to redo the experiment, the researcher took bacteria samples from the one remaining intact flask and placed them on 20 phage plates. And the phage, in this case, are the antibiotic that we're using, looking for resistance to. So what would you expect to see when the 20 phage plates were examined, and how would these compare with those of the original experiment? So what he essentially did was, instead of having all these independent cultures, was he threw out all of them but one, and then used that one culture to put some of those bacteria on all the plates. And if you did this, what would happen is that because this culture is already grown up, it already has however many resistant bacteria it's going to have. If you took this and just plated it out on 20 different plates, you would see about the same number of colonies on each of those 20 different plates. And this essentially defeats the entire purpose of the experiment. So this would give a result which is very inconsistent with the fluctuation test. So instead of seeing all these fluctuations because of what happened in all these different cultures as they grew up, you would just see what happened in that one culture. So you would see very consistent numbers in all the plates. And this would be very sort of the opposite of what you should see in this sort of a fluctuation test.